You're about to watch me reduce a .NET endpoint from almost 19 seconds to less than 100 milliseconds. And the worst part, the bug causing all of this looks like perfectly reasonable code. In this video, we will use Sentry distributed tracing to follow a single request across multiple .NET services, uncover two hidden N+1 problems, and fix both live. Here we have a simple order management API, and we have button to load all orders. So this endpoint returns only 40 rows. No exceptions, no failed requests, every API returns 200 OK. And yet this request takes almost 18 seconds. If you only had logs, this would be painful to debug. But with distributed tracing, the problem becomes obvious almost immediately. So this is the system. 3 services with one database, all running on my local machine, but talking to each other over HTTP, exactly the way they would probably do in production. We have a Blazor Server frontend. When the user clicks load orders in their browser, the Blazor server makes an HTTP call to Orders API to fetch the list of orders. The Orders API owns the order database, which is Postgres running in Docker. Prices live in a separate service, which is Pricing API, and which we call through HTTP client. The point is that it's separate process that Orders API has to call over HTTP whenever it needs a price. So we have mocked some data in our memory database. In pricing API, we have an endpoint that will return a product for a specific product name. So let's go back to the order endpoints. We have just one get orders endpoint where we are trying to get all orders, and for each order item in orders we will try to get price by calling that other price API, and we will return that order summary. You can immediately figure out what's happening here because this example is really simple. But in real case you would probably have a couple of more APIs, and maybe you will have events, a RabbitMQ, and some other stuff, but you will figure out the point of this video on this example. In the program CS of our orders API, the thing important for us here is that we have added OpenTelemetry with some tracing. I have ASP.NET Core instrumentation, HTTP client instrumentation because we are using HTTP client, and I have Entity Framework Core instrumentation. Okay, so let's run those two APIs and let's run our Blazor frontend and see what's happening here. So applications are up and running, and I'm clicking load orders again. And we wait. We have almost 16 seconds for 40 rows. The data is correct, 40 orders, customer names, statuses, dates. We figure out there is a bottleneck in server side, but which server? Is it Orders API? Is it Pricing API? Is the database? We don't know that here. And if I had only logs to go on, I would now spend 20 minutes adding stopwatch calls into different methods, redeploying, waiting for the issue to reproduce, reading log files, repeating. That's a slow path. Let me show you the fast one. You can go to Sentry.io. We can go and create new project. Let's take ASP.NET Core for the platform, and we are going to create our project. We are going to configure our SDK for Sentry in our applications. Before we proceed with configuration, let me quickly explain what Sentry is. Sentry is an application monitoring and observability platform that helps developer react, investigate, and fix issues in their applications much faster. And it gives you visibility into errors, performance bottlenecks, traces, database queries, HTTP calls, and even real user sessions across both front-end and back-end services. So in this video, we will use Sentry's distributed tracing and session replay features to investigate slow .NET application and uncover hidden N+1 problems that we have across those services we are using here. So now let's go back to our application and let's configure ASP.NET Core SDK for Sentry. First thing, before we even add it in program CS, I'm going to add a new NuGet package. So I will search for Sentry and I will install two NuGet packages. I have already done that for Sentry ASP.NET Core. And for another one that you will need for integration with OpenTelemetry if you are using OpenTelemetry is Sentry OpenTelemetry. Okay, let's go to the program CS file and now we can add to our web host Sentry SDK builder web host use Sentry, which will take a delegate. The first thing we are going to set up here is DSN, which is a data source name of a given project in Sentry. That is the project we already created in Sentry. Let's take this from the configuration, and inside of the configuration we will populate this value in a minute. I would like to set up here is traces sample rate. Traces sample rate is a percentage of the tracing data that is collected. I would like just to add support for OpenTelemetry, so use OpenTelemetry integration. And down below, with tracing, I'm going to add Sentry. And for the code, this is all you need to allow Sentry SDK to be inside of your project. The only thing we are missing here is in our app settings, we are missing our source name. And if we go back to the Sentry project, we can see that we already installed it, we configure it. And let's go and run our application to see what will happen with our setup. We have started our Sentry demo project, order management. You can see number of releases, which means that our Sentry project recognizes that our application is up and running. Let's go to explore and let's say, for example, traces. And you can see here all the traces so far that our application have. From the left side in explore, you have traces. You can also set up Sentry logs. You have metrics. You have discover, profiles, replays, and releases. So now let's go to Sentry demo and let's load our orders again. If everything works fine, this is going to record some traces in our Sentry project and we will be able to see what's happening through all microservices. So loaded 40 orders in 18 seconds. I'll go back to traces. Let's quickly refresh it. Let me quickly explain these traces dashboard because a lot of things happening here. You have here a bar chart for count of spans that happening. We have span samples, we have trace samples. You can aggregate trace samples by the value that you select from the left side. If you want to group them by HTTP method, you can select request method and you will have get and post, because in our application we have those two only. You can sort that. For the visualization, you can select whatever you want, count, average, P50, P90, P100. I'm going to search for request method, which is get. We want to find our get orders API. Down below, you can see our get API orders endpoint, which takes 17 seconds. Let's open this trace. So this is entire request. Let me walk through what you're looking at. From the left side, you can see a waterfall of the requests that are happening for that trace. On the right side, you can see a span for each trace, for each request, where you can see some attributes, details, database calls, context. The trace starts in the Blazor server. It goes into orders API. So those are DB query spans. Each one is an entity framework call round trip to PostgreSQL. And if I'm counting, there are, let's say, 40 of them. And you already can see this is a basic N+1 problem that is pretty common in software development. If I scroll down, you can see one select from order items. You can see another select from order items. If you take a look at that CQL, you have select something from order items where order ID is some value. So it's the same query run 40 times, once per order, each one fetching the items for that one specific order. It's 40 because we have 40 orders. Imagine if that number is bigger. But it gets worse. These orange HTTP client spans, each one is an outbound HTTP call from orders API to pricing API. So there are over 200 of them, one per item. Each call takes 15, 20, 30 milliseconds fast individually, but 200 of them in a sequence is most of our 17 seconds. And here is the magic of distributed tracing. So you can click into one of these and I can drill all the way through. Inside the HTTP server span on the order side, Sentry shows me matching transactions on the pricing side, same trace, different service, and I can see the request was actually received. I see what it did, see how long it took. Without distributed tracing, I would have no way to correlate a request on one service with what happened on the other. So now I know exactly where those 17 seconds went. I haven't added a single log line and I haven't attached a debugger. I click a button and read a screen, and I can find out what's happening with my distributed traces and what's happening with my application. Now, when I know the problem, I can solve the problem. Let's fix that N+1 query problem. So I will go to order endpoints, and here we have get orders method. One initial query and then n additional queries, one per result. Inside of the loop, we have n orders. For each order, trip to PostgreSQL. Entity Framework doesn't know how to load items eagerly because we never asked it, so every iteration becomes another database call, which is N+1 problem at a database layer. But there is a second hiding underneath for each item, and there are 240 items across 40 orders. We make a separate HTTP call to API for the prices. That's N+1 problem across services, or sometimes called N+1 over the network, which call now includes network latency. And what makes this dangerous is that neither layer feels wrong when you read it. Loading items for this order sound like the right scope. Asking pricing for this item sounds like a clean abstraction. The bug is calling those lines inside a loop, and the cost scales with your data. 40 orders today, 10,000 orders next year. The endpoint that slows down now will be unusable then. So let's quickly fix this. You already know what is the fix, so I will skip this step and I will quickly explain to you what is done. Okay, the fix is done, and let me quickly go through what I have done here. So this is the database fix. Include method tells Entity Framework to load items together with orders in one go, and Entity Framework will issue 1 or 2 SQL queries total instead of 41. Probably the more important fix here is about distributed fix. Instead of calling pricing API once per item, we collect every product name and ask for them in a single HTTP call. So 240 round trips collapse into one. So this get prices batch async is a new method that will call a new endpoint, which I added in pricing API. I will pass all product names and will return that to the caller in one HTTP call. And that's the entire fix. So let's run this application again and let's go to the Sentry distributed traces to see did we solve it. Application is up and running. Let's click load orders again. And you can see I loaded 40 orders in 100 milliseconds, 200 milliseconds, 100 milliseconds. Okay. Let's go to our traces and let's refresh and let's find our trace. So it's 30 seconds ago. And you can see get API orders. Let's go and take a look on this trace. From here you can see there are much less tracing happening. And look at this trace. Compared to before, the total duration is under 200 milliseconds. Yes, the first one is 900 milliseconds. That's because it was the first call of the API. And instead of 41 database spans, we have only 2 database spans. One for orders with their items and plus the bookkeeping query. We have a single HTTP call to pricing API instead of 240 calls, and one nested transaction in pricing API instead of hundreds of them. So this is what I want you to take away. We are not guessing. We have a before trace and an after trace side by side, showing exactly what changed. Same input, same output, dramatically different work. And that's measurable, defensible proof that the fix did what we wanted exactly. And one last thing I would like to show you is Sentry's session replay. It records what real users actually see and do in their browser. If you go to replace, you can see sessions from your users that you can replay to see what's happening while they're waiting for some responses. And if you take a look on a replay before the fix, you can go inside the replay, you can play that replay and watch this. User clicks, spinner, 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 a couple of seconds of nothing. Their perspective, the application is broken and they don't know there is a N+1 problem, and they might assume their connection is bad, refresh the page, click again and get the same 10 seconds and give up. If I go back to replace and then click it, I think it's this one, and I click load orders. For the first time it will took less than seconds, but after each click you can see it's instantly loaded. On the right side you can see AI summary. You can have AI summary what happened with that user session, and for each action the user have done in their browser you can replay that action. The main focus of this video is to show you traces and replays, and the next video I'm going to cover Sentry's AI agent Seer, which can help you in resolving some issues that you have, in optimizing your performance and much more. Be here for another Sentry's video. If you want to see how logs, metrics and all other things in Sentry works, please write that in the comments. I read all the comments and we will figure out next steps. So we started with a page that took more than 15 seconds and show no errors. But the bug wasn't just in one place. It was distributed across multiple services, in our case 3 services, and hidden inside of reasonable looking code at 2 different layers. So Sentry's distributed tracing turned all of that into a single waterfall, so you could see everything. Database queries, HTTP calls, cross-service transactions, all attached to that one trace in a chronological order with their durations measured correctly. And from there, diagnostics took like 2 or 3 minutes to figure out what's happening in the trace and what is the problem in the application, and it took another 5 minutes to write fix in 10 lines of code. And that's the loop I want you to take away. You don't reach a profile, you don't need to add stopwatch inside of your code, you don't need to grab through logs, you just look at trace, you see the problem, you fix the problem, and you confirm that problem is fixed again in the trace. The full source code is linked down in the description. You have 3 projects and a Docker Compose for PostgreSQL. Run it, break it, try it yourself. Go to Sentry.io and try distributed tracing completely for free. If this kind of content is useful for you, please click that subscribe button. I saw that over 70% of people watching this video are not subscribers, so if you like it, just subscribe. I cover all .NET API architecture topics and some developer tooling regularly. Thank you for watching this video. See you in the next one. Dream big.